Hello, Algebra 2 folks, and welcome to Unit 4 Factoring. You need a pencil or a pen, your foldable notes, maybe a calculator, and definitely your thinking caps. Okay, we're going to start off by recalling how to multiply two binomials. Now, whether you remember it as being double distributing or using the mnemonic FOIL, either way, you'll get the same answer. So let's go ahead and either FOIL this or double distribute it. X times x, that's x squared, because if you have one x and you multiply it by another x to the power of 1, you add the exponents. So x squared. X times negative 1, that's negative 1x. 3 times x, 3x. 3 times negative 1. Negative 3. So notice how I double distributed both the x and the 3 to both of these two parts, the x and the negative 1. And now we can add like terms. So x squared, 1x minus 1x plus 3x is plus 2x. Bring down the negative 3. When I multiplied these two binomials, I get this. Now, you don't have to write this down if you remember how to multiply binomials. But the idea is in order for me to get this answer, I needed these two parts. These two parts, or if you want to say each part, is called a factor. Okay, so let's go back to like 3rd grade. 2 times 3 equals 6. What are the factors of 6? 2 and 3. So two things that multiply to make a number are factors. Okay, so we're going to talk about this a little bit more after we do another example, just to make sure we remember how to multiply, because it's good to know how to multiply. Because if you know how to multiply, then you can check your work to make sure you factored correctly. Okay, so x times x, doubles distributing again, x squared, x times negative 3, negative 3x, 3 times x, 3x, 3 times negative 3, negative 9. Add like terms, x squared, cancel, minus 9. So these two factors multiply, and when added together, they give you x squared minus 9. Right? So thinking about how multiplication relates to factoring. So now if you would take out your foldable, you're going to notice that the first thing we're going to do is flip up the first part, and we're going to talk about factor and what does it mean. And then we're going to talk about the greatest common factoring and how to do that. And then we're going to talk about group factoring. All right, so open up your foldable. And you'll see 2 bullets. And where you see those 2 bullets, we're going to write down what factor means. So factor is to find out what was originally multiplied to create the expression. So if you think back to that 2 slides ago, what we ended up multiplying, and after we multiplied and we got that expression in the end when we added all the like terms, to find out what that was originally multiplied by or multiplied to create that, those were the factors. Okay. Another way to say this is to undo the multiplication process. So it's really important that you know how to multiply, so that when you get factors, you can look at your factors and multiply them back through and say, oh, hey, I got what I started with. Oh, I probably did it right. Okay, so we need to know what our factors are in order for us to make sure we're doing what we're doing correctly. All right, so now we're going to go ahead and talk about the greatest common factor. And how do we greatest common factor? So greatest common factor is factoring out the largest number or variables or both, of each term in the expression. So what do they have in common, and what's the largest they have in common, so that we can divide it out or factor it out. Okay? So here are the 3 examples that we are going to greatest common factor. So you should already have these in your foldable. Okay? So let's go ahead and look at each part and find out what they have in common. Okay, if we're looking at the numbers, they definitely have a 2 in common. But I think they have more than 2 in common. And the big idea is here, you have to take the greatest common factor. So not just any factor. Yeah, they all have a 2 in common. That's not the best. That's not the greatest. So what is the greatest common factor they have in common? Well, they have a 6 in common. So I'm going to divide 6 out of each term. Okay, so how do we write our answer? Well, the way we write our answer is we will always put the greatest common factor out in front and factor it out. So what are we factoring it? What are we factoring out? We're factoring out a 6. Well, when I factor out a 6, what's left over has to go inside. Okay, so 6x squared divided by 6. Well, that's 1x squared. Negative 12x divided by 6. Negative 2x. 18 divided by 6. 3. Okay, so our answer always looks like this. Greatest common factor out in front. What's left over inside the parentheses. Cool thing about this, again, is that 6 and this part are both factors. And if we multiply the 6 through, we should get back to the original. So 6x squared minus 12x plus 18. That means we factored out, at least we factored out a common factor. Hopefully you're factoring out the greatest, okay? So let's look at 14x to the 4th minus 7x. Well, they have a 7 in common, but they also have 1x in common, okay? They don't have 4 x's in common because this guy, he doesn't have 4. He only has 1. And this one has 4. How many do they have in common? They have 1x in common. So what we can factor out, the greatest common factor that we can factor out is 7x. Now divide each one of these by 7x. 14 divided by 7 is 2. X to the 4th divided by x, that's x to the 3rd. Because he had 4 and you're taking 1 away from him. Now, you can think about that in terms of x's, but please don't think about that in terms of numbers. Numbers are actually divided, but x's are subtracted, okay? Negative 7 divided by 7, negative 1. X divided by x, well, if you have an x and I take an x away from you, you have no x, all right? So now if we were to multiply these factors out, we should get back to the original. 7x times 2x cubed is 14x to the 4th. 1 plus 3 is 4. 7x times negative 1 would be negative 7x. Okay. Example number 3. What does 28, 16, and 8 all have in common? The largest number that can go into any of them is 4. Okay? So they all can be divided by 4. Do they have anything else in common? Well, this person has 2 x's. This term has 5 x's. And this term has 1 x. So how many x's can I take from each? What do they have in common? Well, the most they have in common is 1x. Because you gotta be fair. You can't take 2 from all of them, then they don't have 2 in common. Okay, now let's look at the y. So if I'm looking at the y here, this y has 1, this term has 1y, this term has 1y, and this term has 2 y's. The most I can take from either one of them is 1y. Okay, so what they have in common is 4xy. Now if I divide out a 4xy, what do I have left over? 28 divided by 4, 7. X squared, take out an x, I'll have an x left. Have a y, take that y out, I don't have any y's left. Plus 16 divided by 4 is 4. I have 5 x's, I take one away, I still have 4 left. I had a y, I took the y away, they cancel, no y's left, just like over here. 8 divided by 4, 2. X divided by x cancels out. I have 2 y's, I divide out a y, I have 1 y left. Now if I were to remultiply, 4 times 7, 28. 7 times, or x times x, x squared. Y times no y, 1y. 4 times 4, 16. X times x to the 4th, x to the 5th. Y, bring the y over. 4 times 2, 8. X times, oh, no x would just be an x. And y times y would be y squared. Just remember, you always have to take the greatest. Not just any common factor, but the greatest. That's what GCF stands for. Okay, now if you would go ahead and open up to the next paper, we are going to talk about group factoring. When we use group factoring, we must have 4 terms. Okay, what you're going to do is you're going to group your 4 terms into pairs. And you're going to do some greatest common factoring. And then you're going to factor out what is common one more time. Sounds like we're going to do a lot of greatest common factoring. Good thing we know how to greatest common factor. Okay, so here are the 3 problems we are going to do today in your notes. All right, so we have 4 terms. Group the first 2, group the second 2. What does 2x cubed and 12x squared have in common? The greatest common factor they have in common is a 2x squared. So I'm going to divide out a 2x squared out of each one. What's left over? 2 divided by 2, 1. X cubed divided by x squared, 1x. 12x squared divided by 2x squared. 12 divided by 2, 6. X squared divided by x squared, gonzo. Okay, what I'm going to do is I'm going to go ahead and put that greatest common factor in a different color here. Okay, so that you can see the difference. Those 2 factors multiplied to make those 2 terms. Now, what do these 2 have in common? Well, they both have a 5 and they both have a negative. So you're going to divide out a negative 5. When you divide out a negative 5 from negative 5x, you will get 1x. And negative 30 divided by negative 5 will give you a positive 6. I'm going to do that part in red because I want you to see I have 1x plus 6 when I factor out the negative 5. Okay, so we grouped into pairs and we factored out what was in common. Now we're going to do the second step. Factor out what is in common one more time. What does the 2x squared and the negative 5 have in common? Look, right here. They both have an x plus 6. So you're going to factor out an x plus 6. If you factor out this whole group, what's left over? Well, the 2x squared. If you factor out the x plus 6 out from this guy, this whole group, what's left over? Negative 5. That is group factoring. Those are the two factors that when you multiply, they will give you these 4 terms. Okay, let's try it again. Group these two, group these two. Okay, what do the first two have in common? Well, they have a 2x squared in common. That's just funny that that happened again. I didn't mean for that to happen. So they do have a 2x squared in common. Okay, so I'm going to write 2x squared. When I take out the 2x squared, what's left over? Well, 2 divided by 2 is 1. X cubed divided by x squared is 1x. 4 divided by 2 is 2. And then the x squareds cancel. Okay, now let's look at the next group. What do they have in common? Well, it appears they have nothing in common, but everybody has something in common. They have a 1 in common. So yep, you have to take out the 1. So when you divide by 1, you basically get what you already have, which is fine, but you have to bring out the plus 1. Okay? Now, what do these two factors? Well, they're the same. So what do these two factors have in common? All right, so the 2x squared has an x plus 2 in common with the 1. So if I take out the x plus 2 here, what's left over? 2x squared. If I take the x squared out of this group, what's left over? A plus 1. That would be the factors of this polynomial or this expression. If I multiply these two factors back, I should probably get back to those 4 terms. That's how that works. Okay. Okay, let's do one more. Group, 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 group. Okay, group into pairs, factor out what they have in common. Okay, so what do these two have in common? A 12 and a 9, well, that's a 3. And an x squared and an xy, well, this guy doesn't have a y, so they don't have a y in common, but they definitely have an x in common. So let's take out a 3x. So if I divide out a 3x, what's left over? Oops, sorry about that. What's left over? 12 divided by 3, 4. X squared divided by x, x. 9 divided by 3, 3. X's cancel, and I'm left with a y. Okay? So then what do the other two things have in common? They have, they have a 1, but more specifically, they have a negative 1 in common. So we have to take out the negative 1. And when I take out the negative 1, what's left over? Well, a negative divided by a negative. Oh, they also have a y in common. Be careful. I almost missed that, and you will too. So make sure that you're looking not just at the numbers, but also the variables. Okay, so these guys have a negative 1y in common. All right, so if I divide out a negative 1, I get positive 4. If I divide the y's out, I'm left with an x. Negative 3 divided by negative 1 is positive 3. And I had 2 y's, and I take out a y, and I'm left with 3y. Okay, I don't really need that plus sign in front of that 4. Sometimes things like that will make these look a little different. So I'm going to take that plus sign out, and now they look the same. So what do these two terms have in common? They have a 4x plus 3. So if I take out the 4x plus 3, and I divide it out of this guy, I'm left with a 3x. And if I divide it out of this guy, I'm left with a negative 1y. So the two factors that multiply to make my original problem are these two factors. Okay, so a lot of greatest common factoring going on here. Make sure that you have filled out your foldable, and then we will go ahead and work on some practice. Peace out. We'll see you next time.